Hello everyone, welcome back to my channel. My name is Mohit, and today I will be walking you through about step-by-step guide on how to set up Carpenter inside Elastic Kubernetes Service provided by AWS. So there will be in this video or the walkthrough session, I will be explaining about Carpenter side by side, what things would be prerequisite before installing Carpenter, and also there is a full I have provided the Carpenter versus a cluster autoscaler complete comparison and explanation by using the hand drawing. So I would definitely recommend to check it out and go through some of the use cases. It's only 26 minutes, so it can be pretty handful and very good in understanding once you go through this video, and then we will come to explain and install the Carpenter. Now, if you are a person who is interested in cluster autoscaler, not in Carpenter, that is fine. I have also a step-by-step guide on setting up a cluster autoscaler on your Amazon EKS. So without wasting any further time, let's begin. Now, installing a Carpenter, I'm just going to use the official Carpenter reference guide. Please make sure you've used the version which you want to install versus following the documentation against that version. How do I know which version or which documentation should I follow? Because you can see there is 0.32, 0.37, version 1.0, 1.1. That will going to be matter by the, if I go to the upgrading and the compatibility guide. So you always make sure you check the compatibility metrics, which Kubernetes version you're using versus which Carpenter version is supported against that Kubernetes version. So please make sure you definitely check this out before you begin this lab. And now, interestingly, when I was walking through myself and experiencing and learning about Carpenter, one of the things which I get very interested to know that I don't know why, but the Carpenter community itself only providing two different ways to install the Carpenter. One way is where they are assuming that you don't even have created a cluster and you want to add a Carpenter into it. And the second use case is they provided if you already have a cluster up and running, but you are using cluster autoscaler. I didn't see the case where you have not installed any autoscaling as part of your onboarding. All you have is just a cluster running. So in this guide, what I will be doing is I will be explaining in a way that we are spin up already a Kubernetes cluster inside AWS EKS, and then how to set up or install the whole Carpenter. Now, a couple of things we will be requiring on the utility side, like the AWS CLI, Kubernetes, which is the kubectl, or ekctl, which we'll be using, and Helm. Now, if you want to follow the whole process, it doesn't matter. You can use Terraform, you can use different CDK or infrastructure as a code. It's a whole concept. Today, we will be focusing more about Carpenter rather than how we provisioning those resources. So the first thing first, which is the AWS STS get caller identity. So before we begin or start anything, here you can see I have already cluster up and running inside the Sydney regions. I already logged in inside my account, and I have full administrator permission because this is my sandbox. So make sure whenever you're trying to provision or doing this lab, you make sure you already have the permissions and everything. And here you can see all the status checks and everything is fine. And I'm using a Kubernetes version 1.31. This is going to matter a lot in the case of Carpenter. So please make sure what version of Kubernetes you are currently running. When you try to install Carpenter, you are following the documentation accordingly. So I'm gonna clear my screen. And the first step is AWS STS get caller identity. What this command is trying to do is try to find out my identity information that do I like already, if I am already logged in inside this AWS account or not. So here you can see it's already giving me the output, and I can confirm that this user is me and I'm already logged in inside this account. And as I mentioned already, I already have the full administrator permission, so it shouldn't cause me an issue. Now, the first step is we will be setting up the environment variables. Those environment variables will be utilizing to actually provision the CloudFormation and also on a different places in the case of if you are creating the cluster and so on. So including installing the Helm. But in this case, as I mentioned, that we already have the cluster up and running. But what we don't have is the Carpenter or any autoscaling such as cluster autoscaler is installed. So what we will be doing first step is exporting the environment variables based on the documentation. Now, if you're running a EKS cluster version 1.30, 129, 132, doesn't matter, make sure you just modify this number accordingly. And then also check the Carpenter version is supported against that Kubernetes version or not. We're not going to change the Carpenter namespace, so we'll leave kube-system, which is the kube system namespace, so that all the stuff which we are installing related to Carpenter staying inside this region only. The moment when we enter, it will export, and all the variables are now exported in my as an environment variable inside this terminal. I'm using a warp terminal just in case if you're wondering, and that's how, because I have run this command in the past and it uses an AI based on Rust, so it's automatically filling up those informations for me, which is very handy. I'm not promoting warp. You can use any iTerminal or different Mac terminal. I'm on Mac, but yeah, it doesn't matter whichever the terminal you like to use. The second, after exporting these three environment variables, we also need to set up certain other environment variables such as AWS partition, which going to be AWS. So if you're not using standard partitions, you need to configure for AWS CN, which is China, or US Gov. In our case, we will just going to use AWS partition itself. Cluster name, you need to change the cluster name based on whatever the cluster you already have or you planning to provision that cluster. So in my case, it's a Shermia cluster, so I'm going to set as a Shermia cluster. Then make sure you set your regions right. So currently I'm in Sydney. I'm going to put AP Southeast 2, but if you are in different region, just put your region here. Exporting the AWS account ID is just the AWS STS get caller identity command again, but we are querying the account and outputting the text format so that we can grab the AWS account ID. And then we are also exporting another environment variable called temp out with mk make temporary directory. And then we are exporting three environment variables to find out against your Kubernetes version what's the latest SSM AMI optimized AMIs exist. And you can see here we are not making a call in our AWS account. We are making a call in the AWS services EKS optimize -AMI. And these three commands, you don't need to even log in, because what you're trying to get is you're making a call to grab the AMI ID, and I will show you in the terminal in just 1 or 2 minutes later on, to grab those AMI optimized ID against the Kubernetes version you're running in. And again, we're just getting in the output as a text format. So here I already exported in my cluster name, which is Shermia, my region, same, everything else, nothing. So I'm just going to export that, export all these variables and run. And here you can see, like for example, we are exporting all this ARM, AMD, and GPU. What I'm going to do is I'll show you one for AMD, and you can see it's already showing me this ID. This AMI ID is specific for version 1.31. So please make sure if you are using 130, then you will have a different AMI ID will be in your output variable. Now, before we start creating the install the Helm release for Carpenter, there will be necessary steps we need to take. And one of the main step is about the CloudFormation stack, which will be provisioning some of the resources for us. In this command, which provided by the Carpenter documentation, there are a couple of things they are doing. So they are actually first running a curl command to grabbing the latest Carpenter version, and that version they are grabbing against the version we have set up here. And after setting up that variable, they just grabbing the CloudFormation.yaml against that in the temp out variable, which we also set here. And then what we are doing is we're just running the AWS CLI command to provision it. So if I just copy this directly, please note we have already exported all the variables we are ingesting here. So we don't need to worry about what it's going to do. I need to fill up again? No, because we already set and exported all those environment variables in the CLI. The moment I'm going to run it, in my case, I have already provisioned this CloudFormation stack, so it's not going to ask me or redeploy it again unless there is some changes has been observed. So if I'm just run it, as you can see, it says waiting for the change set to be created, but it's detecting there is no changes to deploy, and the stack name is Carpenter Shermio cluster is up to date. And what I'm going to do is you can go to your CloudFormation and search for your cluster name. In my case, the cluster name is Carpenter-Shermio-cluster, which is this one. And this is the whole stack information, which you can see as well here. I'm just gonna show you. And if we go to the events updates, there are a couple of things it's done. But the main thing is in order to find out what's this CloudFormation stack, which we have provisioned using this command, you can simply go and check out the resources. And if we see the resources, there are a couple of resources has been created, such as your spot interruption rule, schedule change rule, and these are all the event bridge rules. If you go to and click on any of the rules, you can see it's inside the event bridge, the rules, and different rules has been created for checking the health, interruptions. If I go to the rules, you can see there are a couple of other rules I have created in the past. Maybe you have already, if familiar with the service, you have other rules, but if not, forget about it. You just focus on the Carpenter rules, which has been created. So for example, this rule has been created for detecting the patterns on EC2 spot instance, interruption warning on AWS EC2. And you can see the target is my target name, which is the Shermio cluster, and the type is SQS Q type. And you can similarly see there is also creating a manage IAM policy, and also there would be an IAM role. If you click on the role, you can see what permissions has been provided to this role, which is provision. And you can see here it's having the EKS CNI EC2 container registry read role. You can explore whole, and this is all using the manage AWS manage policies, which we can see here itself. All these things which we are looking at this stage is just coming from here itself. So we are not doing anything complex. We're just simply provisioning a CloudFormation stack provided by in the documentation against Kubernetes Carpenter version, which is 1.11 in our case, 1.1.1, sorry. All right, so now if you are following this documentation in a way that you don't even have created a cluster, then you can actually simply run this whole command all the way till here, end of file. You can run that file, no problem. What this command will going to do is it will be creating a cluster for you, and the cluster will be set up based on the cluster name variables we set up earlier. Same the region, same the version, and it will add the tag carpenter.sh discovery with the cluster name. It will also adding the pod identity association, but the pod identity associations required an additional add-on. By default, nowadays, when you provision a Kubernetes cluster inside EKS in AWS, 3 default add-ons are automatically added. Those 3 default add-ons are CoreDNS, Amazon VPC CNI, and kubeproxy. So you can play around. You can provision a new cluster for testing. It can cost you some money, but it's always good for fun, for learning. So you will see these 3 are automatically going to be provisioned and added. But you can actually add more add-ons, informations, such as I have added the Amazon EKS pod identity agent. How do you do it is you simply, you add a at the end is add-ons, and you provide the name of the add-ons EKS pod identity agent. And also what we are doing is we are also adding the IAM identity mapping Again, all these variables we have set up here, so we don't need to worry about anymore. But this IAM identity mapping is actually adding this ARN username and the group inside our AWS auth config. Now, if you don't know what this means, I will go a little more in brief, but you can, while you're listening me, you can actually start provisioning your whole Kubernetes cluster. Now, if the folks who don't have to recreate the cluster because they are following like me, I already have the cluster created, but I'm not using an autoscaling so far now. So this documentation, I need to tweak accordingly to support it because I can't just use it that way. So what I did is I'm simply just going to show here. So this is my sharmia.yaml config. So you can see I have a different tags I have added and annotations. Don't worry, I have a whole YouTube video on how to provision or create a Kubernetes cluster, but also create a managed node groups and everything. And what I'm doing is here is I have this instances I'm using a spot. I set the desired capacity to 1 against all the availability zone. So only this information I had initially at the time of creation of the Sharmia cluster when I created that cluster this morning. What I don't have is the IAM port identity association, IAM identity mapping, or the add-on part. So, and these two are the commands which you need to use before we proceed further. So couple of things we need to do. Now, this tag is going to be very important because this tag will be going to be relying to add it on our, when you're creating a new cluster and you add this tag in the metadata, it will automatically add it across all your the EKS cluster networking side, which is the subnet, security group, your node templates, everywhere. But in our case, if the cluster has been created and if you're going to try to add this tag, it will not going to be added easily. There are a couple of ways. What you can do is like you can actually modify your node group, so it will add it on the node group only, but not on the cluster. So how do we solve this problem? Because we do need this tag to be added across all our launch templates, on the cluster, on our subnets, including our security groups. Because Carpenter will be using that tag to find out which subnets I have available to provision an EC2 instance. Because EC2 instance, for example, you can see here, and if I just open one of the EC2 instance, you can see each EC2 instance is having a subnet ID. So we need to find out, like Cluster Autoscaler needs to find out which subnets it can use, and it can only able to use if you have provided a tag called Carpenter Discovery. So you can see this tag has been added in my case, but this tag was not there when I initially provisioned this Kubernetes cluster. So how do I added that tag? That's where the documentation of migrating from Cluster Autoscaler comes very handy. So we're just gonna skip all this part and we will just gonna go to the add tags and subnet and security group section. All you need to do is just follow this commands. You just simply copy 4 node groups. So what it's going to do is actually listing out your node groups and with the cluster names, and then going to create that tag against these variables we already have exported. So when you just simply run this command is already just going to start adding a tags to your node group. Similarly, we need to add a tags to our launch templates to the node groups once we find out the listing, and same for the security groups. So far, only these 2 steps is what we need to do after creating. If you have not creating a new cluster, you already have the cluster exist, and you're trying to follow this guide where we are not doing this step anymore, but we will need to add few bits and pieces in order to accommodate. The best option you have is simply run this command and run this command and you will be all good. And then you can actually go to inside your node group like I did, and as I showed you, you can just click on any subnet or even EC2, you would see that Carpenter discovery tag has been added. Like this, you can see that tag has been added. If it's not added, Carpenter will not going to work. I can bet you on that. Especially on the subnets, you do need it for the discovery purposes. So please make sure you always have. And if you don't have, what will happen is the Carpenter pod, once you're checking the logs, you will see it's complaining that I cannot find any subnets to provision any node inside it. All right. So now what we will do, okay, and so we added the tag is done. Let's say assume the tag has been added as it should. Now we need to add the IAM pod identity association and the identity mapping. Identity mapping comes later on, but what we need is the pod identity. And what I did is I actually copied this to including the add-on part and just added into the into my Sharmia.yaml, which is my cluster configuration. Now, in order to make the changes for the pod identity association, we need to do something called, we need to follow a documentation how to install this documentation about EKS pod identity association. So Carpenter relies on the pod identity association. If you don't know what is a pod identity association, you can read about it. It's AWS EKS has introduced a new enhanced mechanism called pod identity association for cluster administrator for configuring the Kubernetes application to receive IAM permissions required to connect with the AWS services outside of the cluster. The pod identity association leverages IRSA, however, it makes its configurable directly through the EKS API and eliminates the need of using IAM API together, which means is IAM roles no longer need to reference OIDC providers, which we most of the time use. If you don't know what is the IRSA in EKS, you can simply just Google it and it will just provide you the information about the IAM roles for service account. You can read all about it, how you provision the permissions and everything, and you can also read about OpenID. I think it's already included in this one itself, and you can read more about it, about OIDC provider for your Kubernetes cluster. So we do need to install that new add-on, which is the EKS pod identity add-on. Multiple ways again you can do. One is you click on here and you can see and add that add-on. In my case, I have already added. You can add it through the AWS console GUI, or you can just use the simple EKS ETL create add-on, cluster your cluster name, which is in my case Sharmia cluster. Sorry. So if we just click here, I'll just show it here. And what's the command? Add on. Sorry, cluster. Yeah, so I'm just going to show now here. So all we need to run this command. And you just put your name, making sure you already exported all the variables and everything. So if I just run this command from this terminal, because I already have everything exported, all the variables and everything. It should not do anything because I already have that add-on is created, so that's why it's just skipped, which makes sense. But you can just install it, the add-on, through EKS ETL, or just directly coming here, click on get more add-ons and do the job. Now, once we have installed the add-ons, we will be not worried about any more of the pod associations or anything, but we will be running this command called pod identity association inside this, because remember, we added two parts. One is the pod identity association and the identity mapping. So in order for us to make the changes for what we need to do is we need to run this command, pod identity association. So what this command is going to do is actually inside this sharmia.yaml. Because I added this part later on into the picture after creating the cluster, but I don't have any autoscaling running, so I need to run the EKSETL pod identity association. And the moment when you run it, it will and all this about information, as you can see, it's currently complaining because I already existed. In your case, you will get the you will see it will try to provision and it will try to create it. Behind the scene, it will also use the CloudFormation, which you can see. And you can see here, this is the CloudFormation. I can just copy and I can actually show you the exact CloudFormation it's using. By the way, also, if you're interested to see the whole templates when it's provisioning, you can see the whole YAML configurations, what it's trying to provision. And as I mentioned, in the resource section, we can see. So now I'm just going to cancel this and try to filter out with this one. And this is our pod identity cube system carpenter has been CloudFormation template. You can see the template again, what it's using for. And in the resources, we can see there is a new role has been created for carpenter, which is the Sharmia cluster carpenter. And this itself, this carpenter will going to have permission for the controller policies for images, snapshots, security groups, subnets, and so on. And you can see all the tags has been automatically added. Some of these tags has been added from my this cluster configurations, which you can see here. This is just some basic standard tags I just add for my visibility. So similarly, if you have added any tags, you will see. So this is what's the command. The pod association is tackling this part. Now, in order for the IAM identity mappings to be handled as well for this role, what we need to run is EKSETL create IAM identity mapping, and then you just provide your cluster configuration.yaml file. The moment when you do that, again, it will, in my case, it will going to skip because it already exists and find. Now, what we are trying to do here is, by default, AWS, when you install it, if you go to the config maps and go inside the kube system namespace, here I'm just using a lens. Kubernetes lens is a GUI, which you can use it for your personal use as well, as you can see. So I'm using that for the visualization purpose, but if you don't like GUI, you can simply just run kubectl get config map under kube system. And you can see there is one config map, which is called AWS auth. And this AWS auth is the responsible identity person, which is the main giving the access inside our Kubernetes cluster to different user or the role. And if I just type pod.yaml, we should see, oh, sorry, I forget the kube system. So you can see the whole config map. The same thing I will just gonna quickly show from here. So it makes things much easier. And here we can see the map role. So you can see the groups, the role. This is initially I created a node group. So that's where the node instance role is created. And this carpenter Sharmia cluster role has been added through this command. This command which we run, EKSETL create identity. And here we provided this information. And all this three parts, if you see here, they have already created. The reason why we have to do a little more work than normal, because in our case, the cluster is already created and now we are installing a carpenter. We are not provisioning a new fresh cluster. If you're provisioning a full fresh new cluster, you can simply copy the whole snippet and you just run it. Then you don't have to worry about. But in a situations where the cluster is already there, how I can install the carpenter, that's what we're talking about here. Okay. And that's it. That's all we need to do. We have added the tags, and you make sure you validate the tag is working and fine. And then you make sure the add-on has been added. You can go to your Kubernetes EKS cluster. So if I just go to I'm just going to search here. You go to your EKS, and then you click on the, I'll change my region to Cine, and then you go to the add-ons. You see the add-on is up and running. Once you see the add-on is up and running, you can also validate it's the pod is alive. It's run as a daemon set, so you can simply just go to the daemon set and you can see EKS pod identity agent is there. What does it mean is, if you have, let's say in my case, I have 2 nodes, then 2 pods will be running for EKS identity. If I have 10 nodes, then 10 pod identity agents will be running as a pod, which is come from the daemon set, and we can see everything is running fine. And you can explore the labels has been added, tolerations on it, node affinities, and so on, informations about it. Now, once we have confirmed everything is working fine, now we will be coming to the part where we'll be installing the Helm release for the Carpenter. Again, what we are doing here is we are actually making sure we're logging out of the Helm registry to perform an unauthenticated pull against the public ECR of AWS, and then we will be just running the command either upgrade, if the upgrade is only going to happen if the release is already installed, the chart is installed. But if it's not installed, then passing the -- installed flag will be installing rather than upgrading. And then here we're providing the release name, which is the Carpenter, and this is the chart repository URL, which is the OCI://public.ecr.aws Carpenter/Carpenter. Here the version of Carpenter which we exported at the start while setting up the environment variables, and then we were setting up the namespace. In our case, the namespace is also set up in the environment variable as a kube-system, and then if that namespace doesn't exist, it create. By default, when you install a Kubernetes cluster or anything, it will automatically create it for you, because that's where all the kube configs and every configurations goes. And here we're just setting up, running by some set flags command. We're setting up a cluster name, interruption queue, the resources, request, memories, and so on. So let's just copy this command and run it on our terminal. In my case, I already have installed the release, but you can see it's just logged out, pulling the image, and it just deployed. That's why you can see the version is 2, not 1. And if you don't have installed prior to this video, then you will see revision is 1. You can simply again run the Helm again, because we know it's installed inside the namespace kube system. So what I'm running is I'm running Helm list all the releases inside kube system, and you can see there is only one release called Carpenter exist. There is 2 versions exist for that one. The last time it updated just now in Australian Eastern Standard Time. The status is deployed, what Carpenter chart version versus the app version it's using, and the same information I can also show you directly from here itself. So if I go to Helm and release, and so you can see the whole information. I can also see the user supplied values, and these values has been actually supplied by setting up these values. So you can just see more handful information from here. So that's why I sometimes like to use GUI, which is much interactive as well, and it much makes life easier of a person who's trying to debug or anything. So once you install the Carpenter, the main thing we need to see is the pod up and running fine. So I'm just going to search the pod here, and we can see the pod is actually running fine. If you see the pod is not healthy, there can be several reasons for it. Either it does not have right permissions, or something wrong with or it's not able to deploy it. So make sure you check, does it have it's able to schedule it on any EC2 node. If it does not, you might have to provision an extra node to provide, because we are setting up here of 1 CPU memory and 1 core of CPU. Okay, so once you know the pod is up and healthy, you can click on the pod and check the pod logs. And if I just expand it, you can see there is informations about coming in. In your case, probably you don't see all this information, because I was also set up to play around with something. So now, so far what we have done is we have already a cluster exist. Inside that cluster, we added the tag following this subnets and the security groups tagging by running this command, which is very important. Once we have added the tag for Kubernetes Carpenter discovery for our cluster name, then we will need to set up those environment variables. We are not creating a cluster in this demonstration because, if you're creating a cluster, you don't need to add the tags. But if you are not creating a cluster, we need to add the tags by ourselves. And then we will be setting up the pod identity, pod association, identity mapping, and install the add-ons, which we did. Once everything is done, we will see the EKS pod identity agent, the pods which is running from a daemon set, all are healthy, and then where we install the Carpenter. And we should not see any errors or the pod is restarting. If you see the pod is restarting, then something wrong with the pod permissions on the Carpenter, or if it's not able to schedule, then we probably have to provision some higher EC2 nodes so that it's able to schedule, because we need at least one core of CPU and memory. Now, there are two other things which I have very well explained in this video in the Carpenter about node pool and node classes. So in Carpenter, there is two things. It's called node pool and node classes, which you can see here itself. But while following this documentation, as you can see, there is two information has been a snippet has been provided about node pool. And this node pool is also creating a EC2 node class of the name default called default. And now what we are trying to do here is, and what is a node pool? What is the node class? In a simple terms, node class is where you will be utilizing your AMI selectors. What is an AMI selector? If you remember this ARM ID, if I just export this, we exported all these variables against the Kubernetes version we are running. In my case, it was 1.31. So we get this AMI ID. So and you just run this this command. Not export, echo. So we get this value, which is the AMI ID. So node class is the Carpenter has its own CRDs, customer resource definition, and we leveraging that node class resource definition, and where we providing certain specification. If you open the concept called node classes, you will see it have a huge information about all different things. You can go for specs family, whether you want to use Amazon Linux 2 or Amazon Linux 2023, or the Bottle Rocket, the Windows 2019, Windows 2022. You can go for customs and so many different attributes and the fields it supported. This is the whole list. I'll include it in the documentations you can go through. But for basic, what we need is we need to define the AMI family, whether we want to use Amazon Linux 2 or 2023. The role name is going to be the Carpenter and your cluster name, which we created above using the CloudFormation template as well. The subnets where the tag discoveries will be looking for, and the AMI selectors. And here that AMI selectors IDs is coming from. So all this, they're assuming that we have already exported, and yes, we did. And I will be showing it once we will be running. So node class is nothing. You're just creating a type of a resource definition as a node class, where you will be providing the information about what AMI ID you want to use for which family. You can go for as I mentioned, Windows. You can create multiple different node classes. Nobody's going to stop you. You can create a separate node classes, and then you reference inside the node pools to use which node class you want to use. On the contrary, node pool by name itself, it's like a node pool. So what they try to do is, here you provide the information about the architecture, operating system. You can see they provided a capacity time, and this is just a reference example. If you open the node pool concepts here, you will see it's a huge list of different informations about different specification attributes, the annotations, node class reference, taint, expire, after. Then there are so long list of informations you can add on. But to make things simpler, we will just going to provision only this way. Sorry. And what we are doing also is we have the carpenter.capacity types, and here we set on demand. You can change it to spot. You're also putting the instance category. We are saying compute, memory, M series or the R series. And you can also saying the instance generation is latest. And here you can see we are referencing to the node EC2 node class as a default. And you can create, and as I mentioned, you can create your own EC2 node class, such as call Mohit as an example. And then you pass that node class references here as Mohit rather than default. And that node class, let's say, is only targeting the Windows instance. Then here you just change all these attributes of the node pool to be going for a certain instance category or a generations or the spot versus on-demand capacity types to be on for Windows specific instance. And then you can just provide the AMI for Windows specific only. So what we're going to do is we simply just copy for now, and we run this whole command. The moment what we're doing is just running a cat and a file environment and substitute kubectl apply, and we will be just creating these two, node pool and node class. You can only create these two once you have installed the Helm release and the CRD is installed by you. And here you can see, once I'm gonna do it, you can see in my case node pools for carpenter.sh/default is unchanged. In your case, you will be seeing created because I have already created. And now again, you can just run kubectl the command, which is this one. Let's see if I just copy this, is it going to get me? So you can see I'm able to get the default. You can also what you can choose do is like provide default, which is the name of the node pool, and I can just type output.yaml. Let's just so here you can see I just put output.yaml, and here you can see the whole. So we are setting up a disruption budget. I will be making another video only on the node pool versus node class and how you can tweak around. And here we set up the CPU as 1000 cores. So that means is the total maximum amount of CPU your node pool can go for is 1000 core CPU, which is humongous. And here we are setting up the node for the don't get expired between at least for after 720 hours. So not going to happen before that. And then similarly, all these attributes which we just set up, and this is just the information about the status. That's pretty much it. Now, again, if you are using Lens, you can see from here itself. So you can see the node pool information which we have, and the node class, which is also, you can open it up and you can see the information for node class. For the AMI, I'm using against my optimized images for 131 version. And for ARM, I'm using this AMI. AMD, I'm using this AMI. Now, there is another thing which you just maybe have looked also is node claim. Node claim comes into by from a node pool, which sort of instances to provision, and you can see the list of whole node nodes are coming in, and you can see their informations and everything in the node claim section, which is claimed by Carpenter in provisioning. Another very important thing is these two instances I initially created through ekctl. So if you see any labels or annotations, you can see it's all provisioned from ekctl. We don't see any Carpenter information about the label or the annotation. We don't see anything, the taint or anything has been added. And how do we validate whether our Carpenter is actually working or not? The best way you can do is simply create anything. You can go for anything. I'm just simply provisioning a kubectl create deploy nginx replica of 200 because I do know I am just running here T3 medium or something. Let me just quickly check. So you can see I'm just have a request and limits of not this. If I go here, so you can see 2 and 4 memory and 2 and 4 memory probably. So total is 4 virtual CPU and 8 gigabyte of RAM in total for my whole work nodes. So I do know it's not able to satisfy Nginx for 200 replicas. So, and this is a great way to see if I'm provisioning some new application, how does it going to handle the scalability for me automatically if the Carpenter and the node pool and the node class has been set up completely. So now I have created and since I didn't provide it any namespace, so what will happen is if I just go to the get pods under default, that's where it will be deployed. And you can see all these pods are in pending. The reason is in pending because there is no enough pod exists to able to help them out. So some of them are able to schedule because they going on an existing node. Now, if the Carpenter is working fine, and if we go to the node pool, we can see in the node pool configurations, we have not specified whether should I use M6i large or M6i extra large. All we provide the category of the Carpenter to use, whether it's a C, M, or R in this case, which is the your memory, CPU compute, or the M series, R series, or C series. So one way to quickly check, you can go directly to the nodes to see if the node is provisioned, or you can check in the node claim. You can clearly see a matter of I deployed 56 seconds ago, or now almost a minute ago, C6A 4 times extra large on demand has been provisioned inside AP Southeast 2C. That means is if I go to the node, I should see another node has been added into the picture. So we can see here a new node has been created, and that node is large enough, which is 16 CPU and 32 gigabyte of RAM to handle all the ports which is running in pending to be able to schedule by the Nginx. And this is a problem itself as well. And I have discussed about this disadvantage on Carpenter side in this video itself. If you go and watch this one, one of the key concern you can think is, what if you don't have a good alerting or monitoring system in place on the infrastructure? What will happen is you, without realizing Carpenter, because you are not setting up any limits. Of course, you set up a limit for 1000 CPU, but here we have not specified what type of your instance size is to use. All we said, go for any C, go for any M, go for any R. And clearly, it's spinning up a massive C6A 4 times extra large, which is 16 virtual CPU with so many high RAM as well. So it will gonna cost me a fortune even while spinning up this for the time of the recording a video. But just imagine if somebody is provisioned something like this, and rather than this 200 replicas because they are trying out and you're using a Carpenter, it can spin up. And I've seen in my use case in my workplace where I was playing around, and it spin up a 50 virtual CPU core and with 200 gigabyte RAM. It's a humongous instance. A single instance has been spin up, and that can cost you a fortune. What we try to solve is not only the problem of auto scaling, but also to optimize our cost effectively. And that's where you have to make sure you tune your node pool accordingly, and you limit the size for what type of instances you should be using, so that it does not spin up ridiculously higher just to able to schedule the nodes. Yes, in production you maybe want it, but not in the non-production environments. So you can go through the whole best practices they have here somewhere. I can just simply just search Carpenter best practices, and you will see this is the whole best practices guide information from AWS sites, and that can give you some more information about to provided the instance sizes and information. I would highly recommend to have both Spot versus the node. So I usually just use both Spot and on demand. And if I just remove this, and let's also just to show you guys some another information. So currently we can see itself in the node claim, it's a spin up as an on demand, and we can see all the ports are able to schedule, and this is here. Now let's just quickly delete this Nginx deployment, which means is all the pods are just going to be start terminating, which means is you can see it's reducing down the number 80 pods, 63, and so on. That means is this node is not going to be utilizing. By the way, because we know this is the latest node has been added based on the timestamp, if we click on it, we can see here the labels carpenters. As I mentioned earlier, you won't see when if it's provisioned manually through ekctl or some other way. That's one way to quickly identify whether this node has been provisioned. If you don't want to check the node claim, you can quickly find out by basing the labels. The carpenter is the responsible for provisioning this one. And you can see in a matter of few minutes to seconds, because now we don't running anything, we only have 13 pods. And if we click on the carpenter and see the logs, you will see it will be start sending the signals, hey, there is no much requirement anymore, so we should start planning to terminate this node. So it can take a matter of some times, and you will see that some interruption, some taint toleration has been added, because currently we are spinning up 16 with 32 gigabyte RAM, but we won't need it. And I would love to see how long it takes. It's spin up very fast for us, which we know that it, and here we can see there is a new taint has been added. And we can see the taint is called carpenter.shell/disrupted no schedule, which what does it mean is we have added a taint by the carpenter. That means no pod will be actually going to be running on this node anymore. It's because this node will be going to be terminated soon, and we don't need it. Carpenter is deciding because we are not running anything anymore. So it's don't need it anymore. So, and the moment when this is going to be, which is now terminated, which is pretty fast, we can see the node claim has been finished off. Now here's other interesting thing I'm doing. I'm changing from capacity type on demand I removed to spot. I'm putting now only spot. I'm gonna save just to check. And now again I will be provisioning my Nginx for 200 replicas. And I do know again the pods will not able to schedule it because they don't have enough capacity. So but what we should be seeing now, the node claim should be coming up with the type capacity as spot. And we can see previously it was using 60A 4 times extra large on demand, and now we can see it's using a spot, which we should be using in a non-production environment. And other thing is you can actually leverage is you can actually set up the configuration in a way that you can set up the node pools to provisioning the nodes in across all the availability zones, but making sure your subnets have the right tags for the discovery purposes of the carpenter, and different tags and the different specifications you can add. But the best thing is right now we're able to get into spot, which is much cheaper, at least 80 to 70% cheaper for me as compared to running on demand even in a lower environment. And that's the end of this session and the walkthrough. And we able to successfully install Carpenter. We able to see the scalability and everything. And I will be just going to destroy everything after the session. That's it. And if you have any questions, anything you want to know more about Carpenter, or if you're facing any issues, feel free to shoot your messages in the YouTube video once I will be uploading in, and we can go through it. And feel free to connect with me on LinkedIn as well. This is my LinkedIn. That's pretty much it. Oops, sorry. Yeah, so that's me. Feel free to connect with me if you want to, and I hope you find this session very valuable, and I will see you in the next one. Bye bye.